Hey everyone, welcome back to the channel. Today we're going to be diving into the fascinating world of organic chemistry. Organic chemistry is the study of carbon based compounds, and it's essential to everything from the food we eat to the medicines we take. This topic may sound complex, but we're going to break it down step by step so you'll have a solid understanding of the basics. Let's get into it. So, what exactly is organic chemistry? Simply put, organic chemistry is the branch of chemistry that deals with carbon containing compounds. Carbon is unique because it can form stable bonds with other carbon atoms, creating chains or rings, various lengths and complexities. This flexibility is why carbon forms the backbone of so many compounds, includes fats, and proteins, and even fuels. Organic chemistry explores these compounds, focusing on their structure, properties, and reactions. Let's start with the basics. Hydrocarbons, which are compounds made out of just hydrogen and carbon. There are three main types of hydrocarbons. First, we have alkanes. These have single bonds between carbon atoms. They are also called saturated hydrocarbons because they contain the highest number of hydrogen atoms. Examples include methane, propane. Next, we have alkenes. These contain at least one double bond between carbon atoms. Alkenes are unsaturated, meaning they contain fewer hydrogen atoms. Ethene is a simple example. Lastly, we have alkynes. Alkynes contain at least one triple bond between the carbon atoms. Like alkenes, alkynes are also unsaturated. An example is ethyl. Each type of hydrocarbon has distinct properties, and understanding these basics is crucial as we explore more complex molecules. Now that we know about hydrocarbons, let's look into functional groups. Functional groups are specific groups of atoms within a molecule that determine the molecule's chemical properties. Some key functional groups are the hydroxyl group, which is found in alcohols like ethanol, then the carboxyl group, found in acids such as acetic acid, which gives vinegar its sour taste. Lastly, the amino group, present in amino acids, the building blocks of protein. Each functional group reacts in a specific way, and this property allows us to predict how organic molecules will behave. Next, we look at naming organic compounds. Naming organic compounds may seem kind of intimidating, but it follows a logical system known as IUPAC naming. Here's a simplified approach. Identify the longest carbon chain in the molecule. This forms the base of the name. Next, determine the suffix based on the type of hydrocarbon or functional group. For example, ane for alkanes, ene for alkenes, and ol for alcohols. Next, assign numbers to each carbon in the main chain so that the functional groups get the lowest possible numbers. For example, if we have butane with a hydroxyl group on the second carbon, we'd call it 2-butanol. Using these steps, you can name various organic compounds effortlessly. Let's go over an example. If we have a 3-carbon chain with a double bond on the first carbon, it's called propene. This systematic naming makes it possible to identify the structure just by hearing the name. Alright guys, it's quiz time. Let's see what you've learned so far. Question 1. What's the difference between alkanes and alkenes? Question 2. Name the functional group in vinegar. Question 3. What would you call a 4-carbon chain with a hydroxyl attached? I'm looking forward to seeing your answers down in the comment section below. Alright guys, that wraps up our introduction to organic chemistry. We covered the basics of hydrocarbons, functional groups, and naming conventions. Remember, organic chemistry may seem complex, but with practice, it becomes much easier. If you have questions, feel free to drop them in the comments, and I'll be sure to help out. Don't forget to like, subscribe, and stay tuned for more chemistry videos. Thanks for watching, and I'll see you guys next time. Bye bye.